Hello, my name is Chad Preisler. Today I'm going to be talking about Kafka streams and the outer join. So what is an outer join in Kafka? Well, it's when you take two KStream objects, or two KTable objects, and you join them together using the outer join method. Today I'm going to focus on joining two KStream objects. When you join two KStream objects together, you end up with a window join. The window join can be triggered from either side, the left or the right. When you're doing an outer join, you may end up getting a record on the left that has no match on the right, or vice versa. You may also get two keys that match within the join window, and that join will trigger right away, and you'll end up processing both the left and the right side. It's important to note that when a record comes in on the left that doesn't have a match on the right, or vice versa, those records don't process until the join window closes. The join windows don't close until a record with a timestamp greater than the join window hits each partition. Remember, stream time moves based on each partition in the topic, and to move the stream window, a record has to hit that partition with a timestamp that is greater than the join window. So when might you want to use the outer join in Kafka? Recently in my system, I had two events coming in within a few seconds of each other, and I felt that it was more efficient to process those events together rather than separately. The outer join allowed me to process most of these records together. So now I'd like to share some things with you that I hope will make working with outer joins easy. I like to keep my join windows small when working with the outer join. Why? Because if a record, say, comes in on the left and there are multiple records on the right with the matching key, Kafka is going to match the record on the left with each record on the right. If another record with the same key comes in the same time window, it's going to match the record on the left again with each record on the right. That may or may not be what you want. Depending on what you're doing, you may end up processing a record on the right multiple times. Just be aware of it and keep your join window small to minimize that effect. Another thing you might want to keep in mind is that if your topic has a lot of partitions, and say that these events don't happen that often, or perhaps after hours your stream traffic goes down substantially, if that happens to you, you might end up having a record hit a partition, but not get processed for a long time because another record doesn't come along to move the stream time along. If that happens to you, you might want to try the repartition method on the KStream objects. You can reduce the number of partitions, which will increase the likelihood of a record hitting that partition and moving the stream time. Finally, remember that you have to code for three scenarios: a record only on the left, a record only on the right, and a record on both the left and right. To do this, I often write my unit tests assuming that I'm only going to get the record on the left. Then I write unit tests only getting records on the right. And finally, I write my unit tests getting both records. When I do that, I'm pretty sure that I've covered most of the scenarios I need to be successful. Speaking of unit tests, let's go over some tips and tricks to help you with the topology test driver. When creating the topology test driver, I like to create it with a start time of 0 seconds since the epoch. Then, when I pipe input to each topic, I make sure that I set the time appropriately to either keep the window open or close the window. This allows me to test all those scenarios that we talked about on the previous slide. Okay, so now that we've looked at what the outer join is and how to test it, let's take a look at some code. Okay, let's take a look at some very basic code. What I have here is I'm creating a left stream, and then I'm creating a right stream. Then down here, I'm taking the left stream, I'm calling the outer join method, and I'm joining it with the right stream. This is my value joiner, which gets called every time the stream is triggered. And I'm just taking the two strings and I'm putting them together. Then down here, I define my join window of 10 seconds. And finally, I'm outputting this to a topic called stream output topic. That's really all there is to the outer join code. Now, in the presentation, I had talked about potentially doing a repartition on my streams, and I can do that right here if I want to by calling the repartition method and then giving it the number of partitions that I want. Just make sure that if you do this, that you are sure to repartition both sides of the stream so that you remain co-partitioned. Okay, so that's it for the stream app. Now we're going to take a look at an application that's going to produce some records and consume some records from the stream and show how they match up. Okay, let's take a look at some running code. What I have here is a user interface I built in JavaFX. I can produce records to the left topic. I can produce records to the right topic. In this window, you'll see records that I'm consuming from the left topic. And here you'll see records that I'm consuming from the right topic. In the table below, you'll see records produced by the stream application that we just looked at. So let's produce some records and see what happens. Okay, let's produce some records to the left and right side of the join and see how the stream processor handles it. The first thing I'm going to do is produce a record to the left side, the left topic. The stream is not going to process this record right away because there's no matching key on the right and the join window hadn't closed and no record had advanced the stream time. Now it's been over 10 seconds. If I produce another record to the left side, we're going to see that that first record is now processed by the stream. It got the value on the left and there's no value on the right. Now again, the record with key 2 up here did not process yet because, again, the window hadn't closed and stream time had not been advanced. But if I produce a record to the right side, we're going to see that now the record, the stream processed that record because, again, the join window had closed and I produced a record on the right that moves stream time ahead past the join window's 10 seconds. So now if I produce, let's just say I wanted to produce a bunch of records to each side of the join, and I'm going to do them within the same join window, we should see output down here where we get both the left and the right side of the join. And we're seeing that down here that the key 3 634 matched 637 over here. So we're getting a value on the left and the right, again, because those records were joined within the same join window and the keys matched on the left and the right side. Okay, there's one more thing I want to show you. I've modified my JavaFX application to produce 2 records to the left and 2 records to the right with the same key. So I'm going to run this and I'm going to run them in the same join window. And what you're going to see down here is that we've got 4 records produced by the outer join because they happened in the same window. So 95, so you can see that 897 here joined with 895 and 897, and then we produced another record to the right, 899, which again joined with 895 and 897. So I just wanted you to be aware of, we talked about it a little bit during the presentation, that when the join happens, when the same key appears in the same window, each time that record hits, it's going to join on the other side with the records that have the matching key that are in that window. So we ended up with 4 records in the output. All right, so that's all I wanted to show you for today. I hope you enjoyed the presentation, and I hope you get some use out of the outer join. Thanks.